going over what is MATLAB, what's it used for. I mentioned that, a linear algebra problem, and then go into some code demo, and then just a little bit of resources and fun stuff. All right, so what is MATLAB? MATLAB stands for Matrix Laboratory. Its most distinguishing feature is that it's optimized for vectors, matrices, and linear algebra operations. That was what it was originally built for. But it's expanded to be a popular tool in a variety of technical fields, especially with scientists or engineers, people who need to use a lot of math and do a lot of modeling, and sometimes who are not necessarily computer scientists. It makes it very easy to create and share experiments, you'll see. So the history of MATLAB. MATLAB was invented by Clive Moeller, a math professor at the University of New Mexico. He built it for his students as a hobby. It was built in Fortran for his math students who we wanted to have the ability to use the matrix libraries, but without learning Fortran themselves. Its first version was released in the 1970s. And then in 1984, MathWorks Incorporated was formed, and it was launched as a commercial product. And somewhere in here, it was rewritten in C++, I believe. So what is it used for? Well, it's great for linear algebra, numerical computing, for data analysis and plotting graphs, simulations, especially if you install Simulink Toolbox and models, and also prototyping, because you can create a bunch of stuff pretty fast that you might take a lot longer to do in another programming language. So it's a proprietary software by MathWorks, but you can access it with your UAlbany email, and it's interpreted. Once you download it, you can run it in real time on whatever machine you download it on, and then it's really a specialized programming language. So it has all these toolboxes. This is what they call their libraries, and I believe they sell as separate products, but I think we have access to all of it at UAlbany. So these are the types of things that are in the toolboxes. Toolboxes for math and statistics, for data science, machine learning and deep learning, Simulink, which is those simulation models which I mentioned, robotics, like if you look in the upper right-hand corner of my screen, this is a screenshot of some robotics, something done with the robotics toolbox, which is modeling how a robot can find a path through a warehouse. And this assumes that the warehouse, like it has a map of the warehouse where basic things are, but there's also objects that it doesn't know about. So it's trying to find a way around its objects. So it will run these simulations to see how well the robot can do before it actually puts it out in the wild and try to tweak it and optimize it there. And then optimization problems, which is like the one in the lower left, which I could show later. This is about finding the correct path through a tailwind and in this example, these green areas are headwinds and these red areas are tailwinds. And this line represents a straight path through it. And it's questioning whether you can find a more optimal path to make a shorter route based on where the tailwinds and the headwinds are. So, actually, I think I may have said that wrong. Yes, I just thought about this. The green is the tailwinds, because of course tailwinds are better to go faster. So I'm going to go through a really basic linear algebra, if the sort of thing you might have solved in high school. So suppose you have $3 per pound coffee and some $9 per pound coffee. You'd like to mix them together to create 10 pounds of $6 per pound coffee. How much of each should you use? And of course, you can create two equations for this. One is just x being the $3 per pound coffee and y being the $9 per pound coffee. Add them together and you get 10 pounds of coffee. And then 3x plus 9y equals 60, representing the cost of each of the coffees and the total cost. And so, you just use a little bit of manipulation, multiplication. You multiply the first equation by 3. You subtract it from the second equation, and you come up with the bottom here, 6y equals 30, and y equals 5. Then you can back substitute and see, yes, you need 5 pounds of each, which intuitively makes sense. and that will solve most equations. Now, the way you would write this in matrices and vectors is just 1, 1, 3, 9 at this matrix C, and then these two x's are what you're solving for. And now I use x1 and x2 subscript 2 because that's the convention for vectors, but this is the x and y here. So we're solving for these two variables. And this is ax plus b, and this can also be thought of as when you're multiplying this matrix by this vector, it's really x times this first one plus y times the second one, and you see how it directly maps to this equation. So I wanted to do that because now I'm going to do that in MATLAB. So just to be clear, I know that was very simple, but everyone understands that, right? Does anyone have any questions? All right. So everyone can still hear me, right?
Yep.
Do you have the so does anyone have the online version open?
I'm trying to pull it up. How's everyone else doing?
I have it open.
Okay, good. We got one at least.
It still won't let me, but try it.
What about the MATLAB phone app? You can download the MATLAB app on your phone. I've done it.
Really?
How is it?
How is the MATLAB phone app?
Pretty bad unless you sign in, but I mean they give you like a few free features. Isn't there? There's not. I'm surprised that there's no free feature version of MATLAB Online that you can just like go to. They actually like force you to sign in. By the way, is everyone signing in with like their normal email or their NetID email? Because apparently we like have two of them.
Wait, what do you mean?
You can sign in with like your NetID at albany.edu or your actual email that you're used to seeing.
No, I just signed in with my regular name email, and that's totally fine.
Regular name email. Okay.
Yes. And it sent me an email right away, and I was able to log in. So it was not a big deal.
All right, it's working for me now.
All right. I'm just going to go ahead and do this example in here right on. So this is how you create a matrix by hand in MATLAB. For a row, you say 1, 1, and then to get to the next row, you have to put a semicolon in. And so we'll make that 3, 9. And then what did we say? B is equal to 1060. Except for that should be a column vector. I should have put a semicolon in there. So we can transpose it like so. And you can already see it's very easy to create matrices in MATLAB. And this is the interactive window. Did I mention this? I was going to. In MATLAB, we have regular scripts like you would have in any language, and then you have live scripts, which I'll show you, which are sort of a mix of notes and code and results, and then the interactive command window, which is what I'm using now. And you can see that these are in my workspace now over here. So to solve that same problem that we just did, you can just do A\B. And this is, well, let's say this, x equals A\B. And this is AX equals B. It's solving for B. And then if you do A times X, you get the original thing back. So obviously this is a very simple example. You could do it for huge arrays. One similar kind of problem might be if you had, 30 different products as a company that you wanted to make, and you know how much of each resource that you had. Then you had like about, I don't know, 20 different resources, and each product needed a certain amount of each resource, right? So you could have a matrix representing that, like each product and then each amount of resource that each product needs. And that could be A in this scenario. And then for B, it might be all the resources you have. And you could solve for X in order to figure out how much you should make of each product in order to make use of all your resources.
Carolyn, can you explain in a bit greater detail what the solve for operator is actually taking as a parameter and what it's actually doing?
Okay, so what do you mean by that?
The backslash operator. It's not divide, right? Like you can't divide the matrices, right? Like obviously.
It's not divide.
It's like a solve for operator,
yeah,
right?
It's solving for AX equals B. And I know that if it's a rectangle, if it's not a perfect square, or if it's not a perfectly well-formed problem, it will use least squares regression to figure out what that X is.
So basically, this is just a calculator.
Keep it 1,000, bro. Like,
This is basic operations of what it can do with matrices right now. Yes. Not that it's basically just a calculator, like as a whole program.
So to solve that without the solve for operator, you would normally have to you'd multiply by the inverse of A on both sides at the front. Am I correct about that? Right.
Yes.
So you could also write it like that to solve for it if you wanted to as well. But this backslash notation is just faster, I assume, to the solve for the solve for notation.
Well, that's not what I meant to do.
Like if you wanted to solve for, what are we trying to even solve for? We're trying to solve for X here, right? So you could do inverse A times B. Would that be the same thing?
That's what I meant to do.
What don't they like?
I
Oh,
need
you
to
actually have to
write-
explicitly multiply?
No,
don't
this
think
isn't right.
that's
This
the
isn't
same
right.
thing.
Okay, hold on a second. Let's do this. I was doing transpose, not inverse. This is why. So this should be
That's right.
inverse A, like that. And now, so we have C as the inverse. So C times B. Ta-da, we get our X back.
Okay, good. So I just want to make sure that the solve for is actually just, it really is solving for it. It's not, it's just a nice fast notation for
Yes.
solving for something. Okay, good. I've seen people use that in MATLAB before, and I've always been like, that's some black magic they're using right there. That's impressive. We don't have anything like that in any other language. So you can really see why MATLAB is so specialist and specialized
There's a
for
lot
these
of
algebra operations.
for linear algebra, exactly. And what was I going to say about this? Well, let's create some more matrices. I'm going to clear my screen. I cleared out my workspace, right? So I don't have A or anything anymore. Well, let's make a new one. Let's say random. This is another way to make a matrix. And you can see I just put one argument in, so it's 7 by 7, right? And then, like we just did, we could do B is the inverse. Or if there isn't a real inverse, you could use pseudo inverse, although in this case, we don't need to. A times B is equal to, and then we get the identity matrix back, right? We can also just create an identity matrix, size 5 here. If you wanted to actually just multiply, so A times B is multiplying the matrices, right? And you can see that when I did the A times the inverse of A, we got the identity matrix. If we did A dot star B, then it's going to multiply element-wise. So you can do that as well.
So the dot is for element-wise?
Correct.
Okay, so that's like the Hadamard product?
Yes.
Excellent.
That's exactly what it is, James. Okay, so then we can also do, you can create a matrix of ones. Well, let's give this 2 dimensions now. Or f equals zeros. Are people, I know we're just making matrices now, but are people playing around with this? I know it might be going a little fast if you're trying to copy it. So then, let's see. Maybe I should just go into plotting.
How'd you make that identity matrix again?
Okay, so let's clear for a second. Do you mean when I created one or I created it by multiplication?
You created one. You said D equals, like,
Yeah,
I think it was I.
It's I, but it's like your I, like EYE. It's very cute. So for the identity matrix, I equals I9. Boom. And you have an identity matrix now. Any other questions about this? Okay. And then for vectors, like I did before, I'll just make another one, is you can also make vectors like this. You could say 1 to 10, and it makes it a vector of 1 to 10, or say h equals 1 and then step 10, and then it'll just do, the middle function is for steps. If I wanted to, I still have this answer, right? Answer, there's a temporary variable one. I multiplied it element-wise before, I had this random matrix. If I wanted to get a certain field from that, you could say 1, row 1, let's just say 2. And you see it returns that element. And then, so I think there's something else I want to show you. You can also look inside of these if you click on them. Well, my new answer is just a scalar. But if I look at this, and you can even change things in here if you need to. This is the same thing. If you load an Excel sheet that's like a bunch of data, you could also click on it in here and change it. Now it's a very weird matrix. Okay. I think that is some basic operations. So let's look at some plotting. There are some built-in data sets you can get. I think I have to say, oh, it's Sunspot. And then you can look at it like I was saying here. And this is just, there's a bunch of data sets you can play with. And then this is just one that shows all the dates of, we've apparently been keeping track of sunspots since 1700 and how many sunspots were recorded in each year. So I just thought I would use this to show some basic plotting. These polyfit and polyvals are functions that are doing least squares regression to make a trend line too. So here are the sunspots. Now this is the live script editor, so you can just like write notes in here. You could make code. If you wanted to change this to be a note, you just click text. And if you're presenting it to someone, you can hide the code and just have your thing. It also allows you to do latex. You can insert You could like insert a LaTeX equation in here or other equations. Live Editor it's sort of like a mix of an app and a very powerful language in some ways. All right, so here we have the sunspot, so we're just getting from now. Oh, I should have mentioned this before. If you have this matrix, and this is going to get the entire column. So this is, or sorry, all the rows. Yeah, so it's the entire column. And then, so this is all the rows of column 1, and then all the rows of column 2. That's what this is doing. And then, so you can plot it. So this is the plot of from 1700 to 1990. And you can do things with these. These are interactive plots where you can zoom in on part of it. Let's do this, run. So you can update this code, and then you can say, I'm going to make this a variable, start equals 1700. I'm going to suppress output by putting this in here. And then I'm going to make this a control. So they're just easy ways to like work with plots and various simulations and stuff and add little widgets. And so for here, click on this again. I want it to only go from 1700 to 1990 because that's how far it goes. And so now it was messed up because I hit it before. Try this. All right, so now you want to go, you can hide the code. And you could change, like adjust the start date by hand while you're showing it to someone. And then you know, there's all sorts of like little widgets like that that you can do. Let's see.
I've been sleeping on MATLAB. This is awesome. I didn't know
You like
could
it?
do these live scripts.
Yeah.
This is like Jupyter Notebook, but better.
Oh, I meant to actually say that. Like, if you've used Adaconda's Jupyter Notebook, and live scripts are pretty similar, right? Because you can also do like blocks of code, like you can do in Jupyter Notebook. I don't know what's unhappy about here. Being too slow for me to look. Okay, so let's do another 2D plot. So this is, I'm just going to redo this line by line over here. Clear this. Let's clear our Euler variables. So we're going to say x is equal to 0, and then here it's using a step of pi divided by 100, but I'm going to do a crappier version and say pi divided by 10. So it's just going to have 10 steps, and then it's going to go to 2 pi. And I'm going to suppress, well, no, I don't want to, I want to show you that output. So here you can see it just created this vector, right, that has 20 steps because it's 2 pi. And you know, the middle one is pi, the last one is 2 pi, and then we're going to plot y sine of x. So now here we have our function, and we can just say plot xy. It's going to show up in another window. Being slow? I don't know. It's weird.
You did hit enter, right? Oh, okay.
I did, but I don't know what happened. Okay, I don't think it was, I don't know. So you can see I made this. This one in here is much more smooth because we have 100 steps, but here I was just showing you the 10 steps. It plotted pi. So you can try to do that. You could mess around with it with cosine and stuff. So that's a 2D plot. But a little bit more fun are 3D plots. So here it makes, okay. So we're making a mesh grid, which is, let's do mesh grid. And then I'll do, actually, let's clear this out so you can see better. See what's going on. Okay, so mesh grid. And then I'm just going to say 1 to 10, and the step is implied as 1 if I do that. So this is what a mesh grid looks like if you just make a mesh grid. And here it's doing it from -2.2 to 2. And then when you put it into X and Y, open up these. One of them will be this way and one of them will be the other way, that's all. So Y will look like, nope, I was wrong. I'm confused. Oh, no, this is the same thing because this is from -2 to 2, right? And it's stepping every point 2. And then here, we're using a function that's x, it's taking x, and then it's element-wise multiplying it by e to the -x squared minus y squared. And so there you go. And when this is, again, this is element-wise, it's squaring every element in y, for example. And here we get this nifty plot.
Is surf like a nicer version of the mesh thing?
Yeah.
Oh,
so
wait, I see. Mesh grid is
actually creating the matrix. So if you what this is eventually going to look like is this 7. Mesh grid is creating these x and y that I was showing you. Like it's just doing this is all mesh grid is doing. And then z is that function that I showed you, and it's going to plot the rows versus the columns, and then the values are the heights. So we'll see that in a second. And then so there is one called mesh, right? So let's just do mesh for a second. I don't know if it's just being really slow or if I'm doing something wrong. So I thought, okay, let's try it in here. Mesh. And then we can make this inline too here. So I don't know why this X is here. Okay, so let's run that. So this is what the mesh grid looks like. And then surface would be, if you change it to surface, then it actually has a surface. And these, and again, you could add those controls. And this is, actually, I think I want to do this as surface. Make this surface, right? And then you can see what I was saying about how this is the grid, this is the matrix, right? So it's a 20 by 21, well, 21 by 21 matrix, and then the values are the color, so it's like a heat map. So you can also plot like clear. Another kind of array that you can make is m equals magic. I'm magic squared, except for not like that. And so you can just plot any yeah. I don't know where my figure is hiding. It's very strange. So, but you could try this in your online version. Let's see, what else should we do? You can also make it this way. I want to understand if I have okay, doesn't matter. We'll just do it in here. So if you can make a Z that's like this, that's by using peaks, it will make a matrix that will show you a bunch of, it's good for I don't know. It's really just good for a demo, but you might have, like, if you this is a real data, you might have some optimization problem where you wanted to maximize or minimize to get to some peak in the data. Um, There's a Gaussian plot. Do subplots. So here we're plotting a cylinder, and you can see with the different subplots. Still won't let me make them big. Um, oh, this is being kind of annoying. All right, here we go. You can see how this is the X and this is the Y, and then this is the Z, meaning the heights. Then it comes together to make these cylinder plots. Okay. A simple simulation would be LifeX, showing the game of life. I thought this was kind of neat. This is where you start with a random seed, and this is very simple to make. I'll show you the code in a second. You start with a random seed, and in the game of life, if you have enough active neighbors, if you have, I think, 2 live neighbors, or if you have, well, if you have 3 live neighbors or you have 2 live neighbors and you are alive, then you stay alive or you get activated. And so let's go fast. Random. This is a weird configuration to start. And so, like, some of them take off. I think my computer might be having issues right now. I'm really sorry. Maybe I downloaded too many MATLAB libraries, and oh, here we go. Here's one that takes off a little bit, but it's in a holding pattern. So this is, I wanted to show you this because it's like a very simple simulation and it's very easy to make. And there's like these demos in MATLAB that you can look at. So edit life X. And so it has a little bit of setup to create the window. And then this while loop is just showing each step of the game, like every step of the simulation, right? Expand the universe if necessary. And then, but we have these matrices, right? You have X and Y. And so, well, okay, so the whole thing is a sparse matrix. And we hold it in, because it's a sparse matrix, it's actually, I think, held in a couple of vectors to save on space. And here it's just saying that if X is, if all of the neighbors of X are there's at least 2 neighbors of X, or there's 3, if X is alive and there's at least 2 neighbors of X, or there are 3 neighbors of X, then X is true. And then it just shows the thing for every X is true. And it's not, it's not like looping over the items. It's just using vector operations to do that. Here's an example of that optimization script I was showing you before. optimization demo. Or this is just a little bit of a model about how, like, this is another sort of simulation, but it comes up with this little GUI, and it's easy to make these little, like, this is why I think researchers really like it, is because it's easy to make these little examples that you can sort of just share as an app or put in a live script. And so here, this is trying to find the shortest flight path, you know. So these are red parts are headwinds, these are green parts are tailwinds, and a straight line would go in 12 hours and 19 minutes, but then we can improve it to 12 hours and 15 minutes with this optimization function. Or we can try the global one, see if it does any better. It did slightly better. And then you can change like the wind fields and stuff. So, all right. Yeah. So here's an example of a little simulation of a drop in shallow water, and then when it hits the boundaries, it continues to make waves. So when I don't have all the steps to actually create this, but you can look at the demo code for that too if you want. So these are the kinds of things that the kinds of simulations you would use these graphs for, and that are easy to make once you have the math for it. And then I wanted to point you to especially to this file exchange, because you can, it's sort of like GitHub, but it's easier to just install things in this and look at any sort of script. Oh, I was going to show you some of these. Experiments with MATLAB. Well, this is just a fern that's using matrix transformations to draw a fractal fern. So yeah, and if you go here, you can look at some of the different things that they have, and install different toolboxes. So let's see something. And like if you look at these, then you can open them directly into the MATLAB Online and play with them. So I guess that's what I have mostly today. Do you have any questions?
That was a great presentation, Carolyn. Can we take a look at, so I know in MATLAB, you're strongly discouraged from using traditional programming control structures if you can help it. And they prefer if you do everything in terms of matrix operations because it's faster. So do we have an example of a problem that we could do with a for loop in a normal language that's much faster to do with matrix operations in MATLAB? Because I feel like that would be a valuable thing to show people, because I've had this issue before. I remember we were talking about this at a lab meeting like 2 or 3 months ago, where I had like an iterative solution, and Bogdanov was like, you could literally turn this into like a matrix solution, like super easy.
I mean, I don't know if this is a great example, but I think that this could be an iterative thing that they just did with a matrix, where they're checking, because of the way they have all of this stored in a matrix, it makes it really easy to make the simulation, you know?
Right, of
Um,
course, to represent it as the array of on and off cells, essentially.
yeah.
But they're still using traditional control structures, and I see a lot in there. So of course they're
Well, they're doing a
not.
loop for the stages, yeah, of the simulation.
Mm.
Yeah, no, that's a really good question, and I was trying to think of an example of that before the
Yeah,
talk,
me
but I
too.
didn't come up with one.
I've been sitting here and trying to think of one. I'm like, no, I know. There's ones. I mean, I think just right off the top of my head, the algorithm to compute the dot product, that's an instance where literally the dot product
It's just an
as a
operation.
matrix transformation, as
Yeah.
as an operation on matrices.
Yeah.
Otherwise, you have to use a for loop for it. But
I'm trying to think, like,
I'm trying to think of like a normal operation that we would do in like coding night, where it's like we use a for loop for it, but actually it can be done all at the same time using matrix operations instead. Where it would just be
it's like if
quite
you
easy.
have a whole bunch of data in a matrix. Yeah.
And it's way faster to just do a transformation on it than it
Yeah,
is to
exactly.
go through
It-
iteratively on each thing.
And you can, yeah. And if you get in that frame of mind, you can rate a function as a matrix. Then
Exactly.
but I'm trying to think, like, okay, so if you wanted to, I don't know the exact function, but if you wanted to swap two things, right, in an array, or like in a vector, you have like 1, 2, 3, 4, and you wanted to swap I and J, right? And you give me I and J as like I is 3 and J is 4. Then, I mean, you could write this better as like having variables in it, I think, but not for the specific case. But if you said like,
Yeah, you can use a permutation matrix here. I was actually just using one of these. I'm working on an interesting problem with these here.
does this example, do you think is useful?
Yeah. Why don't we show people how you would swap things in an array with a matrix, just in a matrix operation, versus a function that would swap two elements of an array. Just to show people how you can really get things. You can really use matrix operations to do basically everything that you do in like a normal program.
See, there's something weird going on with my MATLAB, and I'm sorry about that. I think my computer is
It just is
upset with me for some reason. But so I guess we should just wait. Maybe you can try to show this, James.
Yeah, sure.
You have your thing open?
Yeah, I'll pull it up. Hang on. Let me just move some windows around. Oh, of course I X'd out of it by accident. Hang on, let me pull it back up. Please don't log me out. Please? Okay, good. Clean.
Discord.
I'll share screen. Oh, while I do this, see if you can like Google problems that like common problems that can be solved using matrices that like normal programmers would see. Also, I think maybe we can go over some control structure because I feel like we went over a lot of just like the basic functions and stuff, but we didn't really show off like the control structure, how like weird for loops are in MATLAB, and how to write.
That weird. They're just like for and then end.
Like,
I don't know.
I think it's interesting to draw the comparison between Python and MATLAB, and how Python is literally just like a worse clone of MATLAB, but like that's like open source and like people actually use. All right, let's see.
Yeah,
Everyone
MATLAB combined with NumPy has become, I think, pretty competitive, but it doesn't have those convenient features that I think a lot of researchers like the live script stuff. And you can also export that to LaTeX too, like when you
and it's not integrated. Like it's so nice to have like, because in Python you're importing the plot library, you're importing your like this just has it all built in. Like I have my plot right here. Look at this, it's beautiful. So all right, let's see. Let's do okay, so say we have an array, let's call it A, and we will have him be 1, 2. I don't think you don't need parentheses, do you? It's spaces to separate an array, right? Okay, good. So I have this this A 1 2 3 4, and let's say I want to shift this array down by 1. I want to
Arrays, because this is, let me just mention one thing, because it's all matrix space and they're thinking in that way, arrays are one index based. Yes, but they're also one index based on one.
Oh, that's right. Yes, that's MATLAB is index 1 instead of 0, which is very weird to get used to. That threw me off a lot when writing MATLAB programs last semester. They probably do. But for us, as programmers, trying to access at 1 is like counterintuitive at this point because we're just so used to it from years of accessing, having arrays start at 0, that now that we're starting at 1, it's pretty wacky. Okay, so there's a special kind of matrix called a permutation matrix, where it's essentially 1s and 0s, and you can use it to rearrange elements in a vector. So I'm probably going to do this wrong the first time, but let's see if I can remember this. So the downshift matrix for, you know what, let's do a list of 3, and then I'll actually have this memorized. So it's 0, 0, 1 on the first row, then it's 1 0 0, and then it is 1. Yeah, I'm gonna switch it over to 3 because I don't want to type out the. I mean, I can type out 4. Why not? Why not? Okay. So then we'll do. It's gonna be the bottom 2 or the bottom 3 to shift down by 1. I think it has to be because okay, so it's the bottom 3. So it's still. And it's 1 0 0 0, and then it is next line is 0 1 0 0. Next line will be 0 0 1 0. That's probably wrong. I think this is wrong. Am I insane? I think they should all be shifted over by 1.
Which ones are you trying to?
No, this is right. This is right because the diagonal is all 0s. I'm trying to shift everything over by 1.
Okay, go ahead.
Yeah. So this is. I'm pretty sure this is right. I just used this the other day.
You're gonna shift the first one to the fourth. Oh, that's what you want.
Yeah. I want to shift the fourth to the first and everything else back down. So this is right. Good. So this is our permutation matrix that performs the operation of downshifting. And this is one of the cool things about matrices is they're not just, even though it always, you're basically taught them as like these magic boxes of numbers that you use to solve equations, but actually matrices can correspond to like functions essentially, and it's extremely cool to see that you can, just by plugging in numbers to the square grid, you can do transformations on all of these things. So so if I want to name it. How do I name it? P equals ANS. I want to name it P for permutation. And now I do. Can everyone see this, by the way? Is this too small? It would be better if I zoomed in. Is there a zoom in button? I'm going to zoom in a bit. Or try to zoom in a bit. Oh, yeah. There we go. How's this? Is this better? I'm going to assume this is better. Okay, so we're going to do P times... I might have to transpose that. Oh, I don't think I did actually. Okay, so as you can see, applying the matrix to this shifts the bottom 3 down 1 and moves the bottom 1 up back to the top. So I did have to transpose that, right? Okay, good. Yeah. So I did have to transpose it, yeah. So essentially now we have this row vector, but we could also transpose this back. And when I say transpose, I literally just mean switch from a row to a column, essentially. So as you can see, applying that matrix, that special transformation matrix, we were able to, in a single operation, shift everything down by 1 and shift the bottom 1 back up to the top, right? But if we wanted to write an algorithm to do this instead of using a matrix, we would essentially have to write an algorithm that literally moves everything over 1 and then takes the last element and puts it in there. And I'm not going to write that algorithm out, but I'm imagining you can picture what that does, right? What's the... I feel stupid because I can't think of what the 2x2 one is, because we can actually write the swap algorithm out to show off how you would swap it algorithmically. versus how you would do swap with a matrix. I'm assuming it's 1, 1. I could be crazy. Let's try it. All right, so I'm gonna create this new permutation matrix, and it is going to be 0, 1, 1, 0. Nope, that is wrong, I think. Nope, that's right. Okay, so this is our new permutation matrix. Our new thing is going to be, let's create, can I put arbitrary things in here, Carolyn? Can I put like characters and strings in my matrix? Are they
wants
gonna
it
get
to
mad
be
at
the
me?
same data type. But
Okay, but if
why don't you just try and find out?
All right, let's make an attempt. So we're gonna have A and B in here, and it's gonna yell at me. Oh, okay. So it's a 1 by 2 string array. They're not gonna like the matrix multiplication with strings. They're gonna yell at this. If I do P times A transpose, yeah, unfortunate. That's what I thought. Okay, so let's switch A over to B 1 and 2 instead, rather than our
Wait,
string.
if you really want, well, never mind.
And now we can see that and if we do the second transpose just to make it extra clear, whoops, don't want that. We see that we've swapped 1, 2 to 2, 1, essentially using matrix operations in MATLAB. Where if we were doing this with a function, let's see if I can create a new script. Let's create a new script. I'm just going to go over the function syntax really quick. The function syntax is really weird in MATLAB because you don't actually have a return. You create a variable at the start that you say you're going to return. So the way you declare a function in MATLAB, you type out function as the keyword. Then you type the variable that's going to be your return variable. I like to call all of my return variables RV, even in normal programming languages. You say equal, and then I think over here, it's parentheses and then the list. Oh, no, it's the name. Okay, so we'll call this swap. And this is going to be your parameters in here. And it's not typed, so you don't actually have to specify types. It's kind of like Python or JavaScript, where you just pass things in without caring about the type. So we're going to take in an A and a B. I think I have to separate them by comma. And then you have to specify end at the end. And it just automatically puts that in there. So the way that you normally swap two variables is I actually don't have to return anything. So because I'm not returning anything, I don't even have to touch the RV value since this is a void function. We just care about, Caroline, I just want to make sure MATLAB is passed by reference by default, right? There's not going to be any weird special syntaxes, because if there is, this is going to fail really quick. So what we have to do is we have to say temp equals A, and then we say A equals B, and then B equals temp. Please tell me I'm not stupid. Please tell me this works. A, B, B equals temp. Okay, off the top of my head, that looks good. I'm pretty sure I know how to write a swap function. I hope I'm able to write a swap function. So if we just run swap on, let's create an A and a B. A equals 1. B equals 2. What are they yelling at me for? A usage might be invalid MATLAB syntax. What, do they want me to make a lowercase? They might want this above the function. They might yell at me for not having this above the function. Let's try this. Okay, I'm not getting any more invalid syntax. Now let's see if it actually works. How do you print again? It's dis? Yes, display the value of a variable. So we are going to then disp A and disp B after the swap. Now we will name this swap.m for our script name. We will run it. And what are they yelling at me for? Line 5. Error in temp equals A. Not enough in, forgot to pass in A and B. Great. Okay. So ideally we should see this return to 1. It's the same script. I ain't change it. I didn't want to save it. I just want to run it. I'm not hitting run and save. I'm just hitting run. Already exists. I know I'm editing it. Okay. As we can see, it does not pass by reference. This is unfortunate. How do I pass by reference? All right, let's make an attempt. MATLAB pass by reference. This is new to me as well. Can MATLAB pass by reference? It's not looking good. Okay, so you have to pass in what, objects of it? Or what's this PRPI thing? You know, I don't think we swap by reference, but you know what? To cheat, I'm just gonna not even have it be a function. I'm literally just going to take it out and put it in line. Beautiful. Okay, so this is, if I save and run, we see that we have successfully swapped from 1, 2 to 2, 1 in MATLAB. Now, this is just the normal swap algorithm. This is the boring way you do it in any other programming language. But because we have access to these matrix operations in MATLAB, I will again write our cool permutation matrix. And we will actually, can I do this with matrices instead? That would probably be cooler. If I had a matrix and I swapped the positions. Like, so say we have 1 and 2. They're not going to like this. I can taste it now. And then we say that temp equals, well, we'll call this A. Sure. We'll say temp equals A sub. What's the what's the subscript operator? Is it? I always forget
you want
this.
parentheses?
Oh, that's right. Okay, good thing I
Parentheses.
asked.
So
Yeah,
let's do 1,
So
1.
one. I can just do one. Do I actually
Yes,
do I have to specify both?
Nope.
Okay, good. So we're just going for the first
Oh,
one,
good.
and then we're going to go A sub 1 equals A sub 2, and this is really weird because we are literally accessing 1 and 2 instead of 0 and 1. It just feels wrong. And then we're going to, okay, so this is going to be before the swap, and this is going to be after the swap. So I'm going to do a disp before the swap as well, right? And then I'm going to reassign A to be this, to be nice and pure. Then I'm going to get this. You know what? We can just like apply it in line, right? We don't even have to. I can literally just say A equals 0, 1, colon 0, 1 times, I imagine this works, times A transpose, and then transpose the result. And we just swapped in one line, which potentially I have to check. So let's display A before, and let's display A after. All right, let's pray for success. Oh, look at that. 1, 2 before the swap. 2, 1 swapped. 1, 2, 2, 2. Oh, I messed this up. It's supposed to.
Yeah.
Whoops.
You know what it was supposed to do?
What's that?
It did what it was supposed to do for what you wrote.
Oh yeah. The computer will always do.
Right? I don't know.
The computer will always do what you tell it to do,
Yes,
not
it
what
is.
you think you've told it to do.
Exactly.
So as you can see, we have successfully written the same program. This one uses the traditional swap. This one uses a matrix operation to swap. You can represent many operations using matrices. Swap is just one of them, and there's tons of other ones.
If you were doing this swap and you're doing it for like a whole bunch of them, then you would loop through the array, right? Or you're just doing it for 2 right now.
Yeah, if you had to do
And
it for a lot of them, to do the
one line.
shift.
Yeah.
Yeah.
So it would just be one line in MATLAB that's using this matrix transformation with a permutation matrix. So yeah, that's a simple example.
Let's see what Dan has to say in the chat. So there's no way to assign the variable to just an arbitrary letter. I had a question the other day on my homework trying to find the Cartesian product A times B times C. where A was A, B, C, and B was X, Y, and C was 1, 2. Okay, how do you do Cartesian products in MATLAB? I know you can. I'm trying to remember how. Is it cross? Isn't cross cross product? I think. Can I get some confirmation on
Yes,
that?
I think so.
Cross is cross
But-
product. Dot is dot product. Which is linear algebra operations. Yeah. I'm trying to think of how you would, because you're basically you want to. So the entire idea of the Cartesian product is that you're creating tuples of all of the stuff in those three sets, right? And what's weird is the fact that they're using arrays and not sets. I don't know if does MATLAB have native supports for working with sets? Because I imagine if they do, there has to be a built-in Cartesian product, right?
Product. It's just Cartesian, I think.
Just Cartesian? All right, let's try this. I'd be interested to see this. So if we have A equals, can I literally just do A, B, C as arbitrary?
That's not right. Never mind.
I don't know what just
That is
happened.
not true. It's not Cartesian. Hold on.
I'm not trying to. It's trying to fix
This
it.
is a function that somebody wrote that I was looking at.
Hang on, let me.
It's not built in.
All right, let's clear. Okay, so let's say A equals. So I don't think you can do arbitrary letters. Like if I just say A equals A, B, C, they're gonna yell at me and be like, A, B, C isn't defined. Why does it keep doing this? I'm not. Okay, yeah. So I think the way that you would do this is using strings
Yeah, I mean, I was just thinking that too. You could do it with strings, right? But
you kind of have to. Oh no, it combines
characters.
character constants into one thing. So we would actually have to use. Okay. I was wondering if MATLAB was a character constant language or a single quotations are just more strings. Okay, so there's our 1x3 string array, right? So if we want to combine this with another array, see this is where things get interesting. So A is that, B is going to be what, X and Y? Okay, let's take a look. X, Y, okay. And then C is 1, 2. 1, 2. Okay, so our goal is to, with the Cartesian product, is to create tuples. So did they want you to find an algorithm, or did they want you to find like a, because the algorithm for Cartesian product is pretty straightforward. It's, you literally just go, it's like a triple for loop for whatever. Yeah, okay, so if they want this using, well, I don't think you could do this with matrix operations since it's A, B, and C. There has to be a Cartesian product thing in MATLAB. All right, let's think this through real quick. So we could code up a Cartesian product function that essentially, okay, you know what? We're moving back to swap.m. We're gonna edit this to be the thing. Okay, so ABC, ABC. While I work on the normal algorithm to show off this stuff, Callan, can you figure out if there's a way to do it with sets, if they're like natively supported? Let's see. BC, C equals 1, 2. Okay, so I think the best course of action here is to make a function that returns the Cartesian Oh, this is tough because they want a triple Cartesian product. They don't want. So do they want the triple Cartesian product, or do they want it one Cartesian product and then Cartesian product with another Cartesian product? Because then you're basically putting a two tuple into a two tuple. So you're putting a pair as the first element into a pair. So normally when they want that, they put parentheses around one of the Cartesian products. So essentially the difference in what I'm saying is normally results of a Cartesian product, I'm typing this in the chat, are going to look like A, B, C. But Sometimes they do this instead, where it's A, B is the first product, and then C as the thing that gets Cartesian product with the Cartesian product. And it's confusing syntax when you have more than two things that you're Cartesian producting together, essentially. But I think they want the triple, so I'm just going to assume they want the triple product, and we're just going to write a function to do the triple instead of the pair with the pair inside of it. Okay, I can't spell today. Let's see, function. Okay, good. RV, so that's going to be our list, and we're going to call this triple cart. And we are going to pass in three things. We're going to pass in an A, a B, and our C. And these are each going to be our lists. Okay, so there's our end. And so what we want to do essentially is append to our RV array. We're going to make RV an array. And then we are going to append. And this is not a very MATLAB. By no means, this does not feel like a very MATLAB-y solution at all. I wish it was a more MATLAB-y solution, but I'm essentially going to use the normal syntax. So, oh boy, here comes my first for loop in MATLAB in for ages. Oh, please let me, come on, give me like a nice for loop, a nice for loop thing. I think they have, what, they're for in, right? They do for in. I don't think it's in. I think it's for variable in, and I thought you were supposed to do like their special list syntax. How do you get list lengths in MATLAB? Is it just len? It turned purple. I like the look of that. Oh, it's not purple anymore. All right. Time to pull up the reference document. MATLAB.
It's
array.
length, I believe.
Dot length? Or length like...
Length.
Length. Okay. So, okay. This is gonna be...
I don't think there's a built-in Cartesian. I mean, they do have some, built-in set stuff, but not for that. Because people are making functions for it, and they're all loops and stuff, so...
No, Dan, it's good. We get to show off how to do loops in MATLAB. This is the perfect opportunity because we're going to use a triple for loop here for all three of them. Actually, we don't
I feel like this is easy to do by hand.
a triple for loop. We want a... Because it's a set, and we don't want to... We just want to create all possible combinations. We don't want order to matter, essentially, which is annoying because essentially means we have to like run a post check on it and then take things out. But there's got to be an easier algorithm for Cartesian product with sets. I've never actually thought about this in terms of sets before. Are we sure MATLAB doesn't have MATLAB set operations? Unique, join.
It just, that's what I was trying to say. It just doesn't have Cartesian.
Yeah, it has some stuff. Let's take a look. So, but this is better because we can actually at least use this. Is there a way to express Cartesian products through set operations? There totally is. I'm just too stupid to figure out how to do it. Let's see. What's the constructor, though? They don't really specify here. If I go into one of these, returns the data common to both A and B. So do they not care? It's just an array. There's no actual set object. So is there a way to... So like if I union an array with itself, it will delete all duplicates in a set union because it's interpreting it as a set, potentially. If I do a... Oh, wait, unique. I think this is what we were looking for. Okay. So we can use this, I think, essentially. If we're just turning everything into new lists, then we can just run unique. And it should... No, it's not. That's not going to work. Because we need the uniques between... Yeah, this is actually a hard problem. Wow. I didn't expect this to be so difficult to actually reason through how you would do Cartesian products in MATLAB. This is interesting. I think we should why don't we postpone this for side project development night tomorrow? If you want to come with this question, we can take a deeper dive into this. But I would say, in the interest of saving the workshop and handing things back to Carolyn so she can go over some control structures, we will look at this another time.
I mean, I think I'm done. If you want to do anything more, feel free. But I think that's
We're good. Okay.
Yeah.
I think we should probably just go over like basic syntax before we wrap things up. So like if we want to go over, so we've already gone over functions. Yeah, let's go over if then, and let's figure out how to do for loops because I've completely forgotten for loop syntax. What's the for loop syntax? It's not for in.
It's just for
variable equals? Was it? Colon? No, colon is the separator that you use. I'm just trying to remember what the next word is. Let's look it up.
For index equals values. Statements. And then you have an end at the bottom.
Equals. Okay. Pain. Okay. For I equals, and then you have your start and your end. So this is very much like Python's range function, where you're generating the range that the for loop is going through, essentially. Don't they like about this? An end might be missing. Oh, yes, because we don't have closing braces. We just have end. Okay, let's just do some basic stuff. Let's create a function that prints out the first 5 numbers. Sure. Let's call it print. And we won't take any parameters. And we'll just go 1 to, we'll take out in a parameter n however many numbers we want to print. So this is from 1 to n. We will display n. This is just going to print the first 5 numbers for us. It should. We'll see. My current track record today, it very well may break. Oh, look at that. It broke. It doesn't like it. Do I need is it a ban or something? Do I need no, that looks right. I equals 1 to n. Is it this? Not enough input arguments, obviously. All right, so let's print out the first 5 numbers. Let's see if this works. Oh, it printed out 5 every single time because I'm printing out n, not I. There we go. It's late. I'm tired. All right. 1, 2, 3, 4, 5. Beautiful. So here we have an example of how you do a for loop in MATLAB, and here's a function in MATLAB. What more could you want? Well, we could probably ask for if statements as well. So let's do if. Let's only print out the even numbers. So let's add a constraint in this for loop where we first check if what's modulo in MATLAB? Is it just, no, comment. Oh, that's weird. I forgot in MATLAB comments are percent signs. So what do you do for modulo in that case? Time to look it up. Mod. Oh, you actually have to use the mod function instead. Interesting. So 23 modulo 5, first, second, that's what I thought. So mod I 2. And I don't think it's double equal. Is it double equals? What's the comparison that they use? I'm pretty sure I'm going to assume it's double equals, and then I'm going to get proved wrong. Okay, good. So if, now let's do an and. Do you not need a then? Is it then? I thought you needed an and in MATLAB.
Just if.
I'm getting
if expression should be
it's giving me Lua vibes, and I'm getting like flashbacks to Lua, which is another language I don't program in nearly enough. Okay, so with that, we printed out all the even numbers between 2 and 5. So there you have it. You got your if statements, you have your for loops, You have your functions. We're not going to go for while loops because
For
it's
loops.
suffering.
Yeah.
Does anyone have any questions about syntax? No? Good? We good? Well, that's nice. Very successful. Okay. Well, if that's everything, Carolyn, you don't have anything else you wanna?
Nope.
Nothing? Okay. Good. In that case, thank you, Carolyn, for giving the workshop. It's been a lot of fun. I learned a lot. I'm really sleeping on MATLAB. Most of the stuff that I've done in MATLAB has been stuff like this, where it's just like very basic math stuff. But I didn't realize that you have like the ability with those MLX files
Yeah, they're
to
nice.
like, wow, they're very impressive. I love that. It's beautiful. I'll definitely be using some of those from now on. Like I've been struggling to create GUIs in Python to showcase my data and everything. It's no longer necessary. I can
making
just
GUIs for data in MATLAB is like where it shines. It's like really easy to do a whole lot.
yeah, I'm a big fan. I think I'm gonna swap over to that. Yeah, I'm enjoying MATLAB. I think that the fact that what's important to remember about MATLAB, and if there's one thing you should take away from this workshop, is matrix operations are very cool and very efficient, and you should get used to using them, especially if you haven't taken linear algebra yet. You're going to thank us later when you have to use matrix operations for everything. So I'd say that's a big takeaway. Also, if you ever do computer graphics and like 3D graphics on computers, everything is a matrix transformation, and it's very painful. So it's good to get started learning your matrix transformations now, and MATLAB is a great way to do that. Anyway, with that, I think I'll just finish off by going over the schedule for the week, and then we can wrap things up. So let's take a look at our schedule for the rest of the week. Tomorrow is going to be side project development night. Essentially, I think I'm going to be focusing. I'm interested in that Cartesian product question. So Dan, if you want to come to that, we will discuss that. Otherwise, me and Matt Keelan are probably going to discuss the Connect 4 problem again. I've generalized it to arbitrary dimensions, so that's going to be fun to talk about. Yeah, and beyond that, anyone who has any side project related questions or ideas wants to show off. And we're actually starting tomorrow night. We're going to be turning part of side project development night into a second coding night. So if you want to get algorithm practice, Matt Keelan is actually going to lead some algorithm practice in one of the voice channels as well during side project development night tomorrow. For those of you who might not necessarily be at the stage where you're ready to start a big side project and you just want more practice programming before you, step foot into the realm of creating big side projects. Beyond that, I would say for next week, Monday is going to be coding night. Wednesday, we are going to be having our Android workshop from Josh. Josh, do you want to say a few words about your workshop and what it's going to be about?
Yeah, so wait, you can hear me, right?
Yup.
Laughter.
So I'll because it is hard for me, because how should I say it? So I'll do a review for half an hour, and the other half I'll build it's called a surface view camera. To take a picture in Android, there's two ways, using intent and using surface view. In my previous workshop, I used an intent, and for this workshop, I'll be using surface view. So half an hour review, and the other half, surface view camera building.
Yeah, I'm very excited. It sounds like it's going to be a really fun workshop being able to work with the camera and Android. And Android applications are really fun to do. And it's, I know, especially here, most people learn Java as their first language. So it's a lot of fun to be able to take a look at Java in, a real development environment like Android, where you're building apps and everything. So that's going to be a really exciting workshop. I hope everyone shows up to that. Then next Thursday, we're going to be having Professor Phipps come in and give a talk on C#. It's going to be pre-recorded, and he will have a Q&A session after the talk. That's probably going to be at like 7, and the Q&A session is going to begin around 8:30 to 9ish, I would say. So look forward to that. Professor Phipps is probably one of the biggest advocates of C# on campus. He's given many good talks on why he loves C# so much as a programming language, and it's probably going to be very interesting to hear. I've listened to one of his C# talks before, and it was a lot of fun, and it's very interesting because he likes to compare and contrast it to Java, which a lot of people already know. But to see the differences and why he thinks it's better, it's going to be very interesting. So I highly recommend coming to that as well. And then next Friday is also going to be Side Project Development Night again, so stay tuned for that. And with that, does anyone have anything else they'd like to say? Any announcements, any questions about MATLAB before we wrap things up? No? Okay. Well, with that, thank you for coming, everyone. Thank you, Carolyn, for hosting this great workshop. And we will have recordings of it on YouTube probably by 1 or 2 a.m. tonight. Thank you for coming, everyone. Have a good day.